Welcome back to Hectic 99, only the biggest youth television show right here in Mzansi, where you belong. Now, of course, in the beginning of the show, we mentioned that we are going to be having a young special guest in the stew, and I would like to welcome back our astrophysicist, Nathan. How are you doing?
Good, how are you?
I am absolutely amazing. Now,
Hooray.
Before we even get into it, can we please talk about this word, astrophysicist? What are we exactly looking at?
So, in astrophysics, we study space, that sort of thing. So, today I brought something to show you, because there's a kind of an exciting event happening on Thursday, on September 1st, from quarter to 10 until 12. There's going to be a partial solar eclipse that is visible from, at least from Cape Town.
What? Okay, so you say there's going to be a partial solar eclipse.
Yes.
I think as we look on our screen now, that's what it would look like, I guess?
Yep, it'll look something like that. You'll have, it might be a little bit less that's cut out, but it's a partial solar eclipse.
Okay, cool. So now tell me, how do we actually experience a, you said slightly partial, solar eclipse?
I brought a very technical demonstration of how eclipses work. As you can see here, this is very technical.
I see this actually. Is this where this is Cape Town, right?
Yes. So this here's the Earth, and here's the Moon. And so, you know, the Earth revolves around, but the Moon goes around the Earth every 28 days, roughly. And so so there's the Earth, there's the Moon, and here is my amazing sun.
All right, so let's just dim the lights down right now. We're out in space. So I'm just going to continue the rotation right over here.
And so you can see here we've got daylight, and then as the Moon comes in, you'll get a shadow showing up. And you see the shadow there, that's the Moon shadow. That's what an eclipse is. So if you're right in the center of it, you get a total eclipse. But if you're just on the edge, you're going to get a partial solar eclipse.
All right, cool. So Cape Town's only experiencing it because we're not obviously dead in the center of it. It's just, all right, cool.
Yeah.
And you say 1st of September, you say?
Yes.
That's on the Thursday. What time?
Yes. About quarter to 10 until 12.
Wow.
Now, if you want to see it, there's one thing that you shouldn't do. What's one thing you should never ever do?
Wait, I got this. Don't look at the sun.
Yeah. Don't look. Don't stare into the sun. Even if you have the most amazing shades, do not look directly at the sun.
I don't know. I've got these pair of shades that are killer. I'm just
No. So if you want to actually look at the eclipse, probably the best and easiest way to look at it is using something like a pinhole projection. So I've got here.
So can you just repeat that? What was that?
A pinhole projection.
Oh, and that's the name of our experiment today.
Yes. So that's what I have here. It's basically you have a large sheet of paper.
Yes.
Like so. And you have a very small pinhole in the center.
Okay.
And so the paper is going to create a nice shadow.
Okay.
And then you would shine a light.
Can I help you over there?
And
Okay. So before do we need to dim the lights again for this one?
Maybe you should dim the lights.
Hopefully
we can get this to show up.
There we go, thank you.
But when we have this just right, you'll see the light coming through. And so rather than looking directly into the flashlight, which would be bad.
Okay, so let me just, there we go.
Yeah. You don't want to look directly into it. You want to look at the projection of it on the table, on the ground. Cool. And so that's what you would want to do with the solar eclipse.
So what are you saying exactly? I feel like you just said a whole lot of scientific. What am I? Yes.
So what it is you're looking at the projection of the sun through a pinhole. So something else that you can do is if you want to take a photo of it, you actually can do the same sort of thing with your cell phone. Is you take a smaller piece of paper with a pinhole and you put it right over top of the pinhole, right over the camera, and you can take a photograph of it.
What?
So something else that you can also do is if you have a bit more equipment, you have some binoculars or like a telescope, you can cut a hole through your projection screen and you can magnify that projection. But again, don't look through it because you'd go blind and that's a bad thing.
That is definitely a bad thing. We do not want anyone out here. So you're trying to look through this through a projection rather than directly.
Yes.
All right, cool. I get you. So no shades, guys. None of that. No. We don't need that. You just need to be looking through the projection.
Yeah.
Now talk to me about this new discovery that you guys have, of course, It's something about the habitant sphere.
Yes. So there was this recent announcement of a discovery of an exoplanet around a star called Proxima Centauri. So it's Proxima because it's really close. And when I say really close, I mean astrophysics close, which is 4.2 light years. Right now, anything that we have would take about 70,000 years to get there.
Okay.
So, just to show you how they discovered this planet, so I'm going to take, instead of being the Earth and the Moon, now this is a star and a planet. Proxima Centauri.
That's it.
So, normally you'd think about, oh, the planet orbits the star. But it's not quite true. They actually, both the planet and the star orbit a point called the center of mass, and which is a little bit in between them. And so when it starts rotating, the star sort of moves in this little bit of a circle. And so what we can do, just put this down, is we can measure very carefully how much faster it's moving towards, when it's coming towards us and when it's coming away from us. And so that's what's called radial velocity. And so they've looked really carefully and found that this planet there's a planet around there because it's causing the star to wobble. But what's really exciting about it is that it's in what's called the habitable zone of the star. And the habitable zone is basically where we think there might be liquid water. So this planet, it's just a little bit more massive than the Earth. It's very close to the star. 1 year on this planet is about 11 days, so you can live for centuries there.
It's going for a long time.
But a century might not mean quite the same thing.
Most definitely, as it is, of course, all scientific terms. But I just want to say thank you so much for joining us in studio today, and thank you so much for all your experiments. I do, however, understand that on the 1st of September, you say, on that Thursday, 10 to 12, that's when we will experience our partial solar eclipse.
Yeah.
Thank you so much again for joining us in studio. Guys, if you have any questions for our astrophysicists, go on and send them through on live chat. Talking about live chat, hectic.